Good afternoon. Today we are going to review lessons that you had, hopefully in Algebra 1, where we learned how to factor trinomials. So we talked in our last lesson what it means to be a solution. A solution is an actual value that will satisfy an equation. And in the case of a quadratic equation, that solution represents the x-intercept, or where the parabola crosses the x-axis. So hopefully you will recall after this lesson how to use grouping to factor a trinomial. We are going to start off with just the steps that are required to factor a trinomial using grouping. And the first thing we need to do is to remember to put our equation in, I am shedding, in standard form. And if you remember from our previous two lessons, that it would be ax squared plus bx plus c equals, and in our case, it would be y. If I were graphing it, it would be f of x if I were just talking about the general equation, just in a general case. But in our case, it's going to be equal to 0 because we are trying to actually solve to find the x-intercepts. X-intercepts occur when y equals 0. Okay, so we talked last class about how it's always a good idea to factor out the GCF. Possible. If there's not one, then there's nothing you can do there. But if you simplify things by just dividing by 2 and making your numbers smaller, please do it. It's so much easier. The next step is we are going to multiply the a times c to get a product, and then we are going to find the two factors, the two integers whose product is a times c and whose sum is b. So two things that multiply to give us a times c and add up to give us b. We're going to split that bx term into two terms using our two factors that we found in step 4. And then we are going to factor out the GCF of each pair. Once we have it, we're going to write it in factored form. And if you'll remember, factored form looks something like, I'm going to use different letters. No, I'm not. I'm just going to say this would be, sure, p of x plus q, and this might be r of x plus s, something like that. But this would be considered factored form. And I just made up the letters, so forgive me for that. Those are the steps, folks. And if you do this often enough, it becomes pretty easy to do. And it lends itself really well to when we start talking about functions that have a higher exponent than just 2. So we will use grouping again in this unit, or in this year, just with higher degree polynomials. All right, so let's look at an example, because that's sometimes the way we learn best. The first thing I notice is that this one is already in standard form. It's asking me to factor the quadratic, so I'm not actually going to go through the steps of solving with those baby equations. I'm in standard form already. There is no equal sign, so I'm just going to factor. And what I notice is that 2, -9, and -5 have no common greatest common factor, so I don't need to factor out the greatest common factor. So the next thing I'm going to do is I'm going to do that product sum table. I like to identify what my A, my B, and my C are. In this case, A is 2, my B term is -9, and my C term is -5. So I am going to try to find factors of 2 times -5, the product of -10, that add up to -9. All right, so you can just make an old school factor tree or factor table. -1 times 10 is -10. 1 times 10, -10 is -10. I could also do -2 times 5 or 2 times -5. And all of these, when multiplied, will give me -10. If I add these two terms, here I would get a -9, +9. Here is my -9. This would give me a +3, and this would give me a -3. So I should be able to see which of these two factors, when multiplied, gives me -10, and when added will give me a -9. And that is my magic pair. So what I do next is I like to just write the quadratic I was given over here so that I can work with it. And I'm going to split that middle term up into two pieces using my -10 and my +1. And I'm trying to create -9x, so I'm going to throw an x behind here because that's how I create -9x. And hopefully if you check this, -10x plus 1x will combine to make -9x. What we're doing in this process is we are undoing the distributive property that perhaps was done previously. The first term does not change, and my last term does not change. From here, I can use my grouping that I learned, or GCF work that I learned in the previous lesson. I'm going to cover those two terms up so that we're not even bothered with them. Now I ask myself, what is the greatest common factor of 2x squared minus 10x? And I would suggest that this is going to be 2x. So I'm going to divide each of these by 2x. 2x is a factor. And after I do that division, I am left with x minus 5. And I can check my answer. 2x times x is 2x squared, 2x times -5, -10x. So I have factored, using greatest common factor, this set of terms. I'm going to do the same thing over here. And I'm going to ask myself, what's the greatest common factor of 1x and -5? And in this particular case, it's just going to be 1. So I am going to forget which line I'm working on. I'm going to write 1 here because it is one of my factors. And anything divided by 1 is just itself. So now what I should see is I have basically, I'm going to put a plus sign here because this was plus 1x. I have undistributed, or I have factored out x minus 5. You'll notice that it is the same binomial in my parentheses. That binomial is one of my factors. My other factor comes from the two greatest common factors that I factored out. And by doing that, we have factored this quadratic using grouping, and we have written it in factored form. And that actually is it. We are done. All right, should we try another one? Let's see what the next one brings. The first thing I notice about the next one is it's not already in standard form. So to put it in standard form, I need to set it equal to 0. And I'm going to do that by subtracting 3 from both sides. And I end up with an equivalent quadratic that looks like this. The next thing I am going to do is I am going to identify my A, B, and C term. My A term is 8, my B term is -2, and my C term is -3. I'm looking for products of A times C, which is -24, that will add up to a -2. -24, lots of factors here. If you're using a calculator, you can put into y equals, you could do -24 divided by x and look at your table, and it will give you a list of all the factors of 24. You could also do it the old school way and by brute force, just start listing factors. 2 times -12, -2, 12. 3 times -8, -3, 8. 4 times -6, -4 times 6. There's my list of factors. When I add them, I notice that there are some patterns. That's 23. This would give me -10. This gives me a +10. -5, +5. -2, +2. And now when I look to see which of my factors multiplied to give -24 add up to -2, I can identify 4 and -6 as being my magic pair. So I am going to rewrite my middle term using a +4x and a negative 6x. I keep my first term, I keep my last term, and I have now two sets of binomials that I can factor using greatest common factor. The first one, 8x squared plus 4x, I notice has a greatest common factor of 4x. So 4x can be divided out, and when I do that division, I'm left with 2x plus 1. I can do the same thing for the next set of terms. I notice negative 6x and negative 3 both have a negative 2 in common. I'm sorry, negative 3 in common. Didn't sound right, so it took me a moment. So negative 3 is one of my factors, and after I do that division, I end up with 2x plus 1. Negative divided by negative is positive. And when I do my greatest common factor work, I should notice that the terms inside parentheses are the same. And what I have done is I have undistributed, or I have factored out 2x plus 1, and the terms I'm left with provide my other factor, 4x minus 3. So there I have my factored form. In this case, this was set equal to 0, so I'm going to go ahead and write that equals 0 there. And now I need to solve to find the solutions. And to do that, I write my baby equations. And I solve each one. I subtract 1 from both sides, and I divide by 2. And I end up with a solution of negative 1/2. Over here, I would add 3 to both sides, and then divide by 4, and end up with a solution of positive 3/4. And if you remember, this means that my parabola crosses the x-axis at negative 1/2, 0, and it crosses it again at 3/4, 0. And if I wanted to sketch it out, I would be able to do that, and it would look something like that. That's it, folks. That's how we factor by grouping. It is a fantastic way to group. I make fewer mistakes when I do this than when I use quadratic formula, and it will help me later with my higher degree polynomial work. Until next time, have a swell day.